Hello guys, so today I want to explain to you all how to analyze the FTP using the Wireshark. So we open the Wireshark software first, and then first step which is go to the capture, later the interface option, and then when we click, it will appear the menu, the small menu, and then we click the option button, and the option button will appear again, the bigger menu, then all information that I have here. First we tick the capture on all interface, and then we untick the use permissions mode in all interface. In the capture filter, we insert the TCP packet filter, and then we click the button start. After that, we go to the command prompt, which is cmd. We type the FTP space ftp.mcafee.com. After that, we insert the username for the McAfee, which is anonymous. And then we set the password for the user, which is my name itself is Muiz. And then it's called a warning. This is a restrict access system because we have access the system which is not our system. And then we type the dir directory. Then all the information we set to the directory. After that, we insert the ASCII. We type the binary, and then we type again the ASCII, and then we type the hash to print the data from the directory. Okay, after that, we type the get space usage.txt to download the usage text. Okay, after that we go again to the Wireshark to see the information from the XMD. In the filter, we filter the from the command prompt, which is we type the FTP and then we enter. So this is the username that I have insert into the Wireshark, into this MD, and then this is password which is I set before that from this MD, which is Muiz, and this is the port that has responded from this MD. That's all. Thank you.
Hi, I'm Ashraf, and today we'll be analyzing a network activities, which is DNS query traffic. As you can see here, we had captured so many packets by using Wireshark. To view only DNS packet, we need to enter the command udp.port equal to 53. Basically, this command will only view let us view the DNS protocol type of packet. So for today's activity, we'll be choosing standard query wikiversity.org. Next, we'll be moving on to the below section from this panel, which is this section that has Internet 2, Internet Protocol, User Datagram Protocol, and Domain Name System. In the Internet 2, we can see there's two fields below the Internet 2, which is the destination field and the source field. Basically, this destination field is our DNS server MAC address. To prove it right or wrong, we need to run our CMD, which is a command prompt. We need to enter the command ipconfig /all to view our network details, our NIC details, network interface card details. Then we need to enter the command arp-a. So as you can see here, we can see this DNS server carries the IP address 192.168.0.1, and down here, down the command arp-a, we can see that there is this internet address 192.168.0.1 that has a physical address which is 00.0c-e7-0b-01-02. Basically, this IP address and physical address matches the destination field MAC address. We can see here 00 double dot 0C double dot E7 double dot 0B double dot 01 double dot 02. We can clearly see that it matches. Next, the source field is our source MAC address. So to confirm this right or wrong, we need also to use the CMD. Next, we'll be moving on to Internet Protocol version 4. Under the hood of Internet Protocol version 4, we can see there is source IP address and destination IP address. The source IP address is our IP address. To prove it whether it is right or wrong, we need to head on to our IP address. You can see here IPv4 address, which carry the IP address 192.168.0.167, which is the same as our source IP address. So the same thing with the destination IP address. This destination IP address is our DNS server IP address. Next, we'll be moving on to user datagram protocol. We can see there is three type of thing under the user datagram protocol, which is the first thing is source port, destination port, and LAN. The source port carries the number 64,604. Basically, this source port is our dynamic port selected for this DNS query, and the destination port, which carries the number of 53, is our DNS server port, which is the same with the filter box, the command that we had entered it earlier. And there is the LAN, which carry the number 44. And below these three Internet 2, Internet Protocol, User Datagram Protocol, we can see there is a domain name system. Basically, in the domain name system, we can see more details about wikiversity.org. I think that's all from me. Thank you.
Okay, hi everyone. I'm going to show a basic protocol analysis through Wireshark. Okay, I'm going to choose capture options, and then I'm going to choose my active interface, my active connection, which is I'm using now is my Wi-Fi. Okay, we leave it all, the rest of we just leave it, and then we hit the start button. Okay, and then the Wireshark will be capturing from my Wi-Fi, as you can see here. Okay, we have the TCP protocols, SSL, ARP, and it will all begin to populate a lot later on. Okay, so today I'm going to show how to analyze the HTTP protocol. And first, okay, in the filter up here, in this box up here, I'm going to key in HTTP. Okay, so we press enter. So basically there's still no any HTTP request, so I'm going to get a request. I'm going to request for a HTTP website in my browser. So I'm typing HTTP. Okay, I'm using this HTTP ://www.utam.edu.my. Okay, click on it. Okay, here you go. This is the UTM portal website. Okay, you go back to the Wireshark, and it has captured the protocols. Okay, I think I can stop capturing now, stop running the live capture. So I'm just gonna choose this one. Okay, we can see here we have HTTP, the hypertext transfer protocol, is the application layer. The TCP, transmission control protocol, is the transport layer, and the IPv4, the Internet Protocol version 4, is the network layer, and the Ethernet 2 over here is the data link layer. Okay, so we are going to start with the data link layer. So as we can see inside, the data link layer shows us the MAC addresses for our destination and our source. And here, this is my Wi-Fi adapter. This is the address and also my source down here. Okay, my root is my Wi-Fi adapter and my router. Okay, you can see here. So in the IPv4, why it's called version 4? Because we have the IPv6 as well, but it is not yet implemented into the internet. And here we have the header length, it's 20 bytes, and also the total length is 660. Okay, and if we see down here the source here, this source right here inside this IPv4, it shows this is my IP source. This is the source of my IP. Okay, this source is my IP. I mean, sorry, this is my IP, and this destination is the UTM portal website. This is the address. Okay, now we can proceed to the TCP transmission protocol, control protocol. Okay, we have the in here the source port. The source port is the port that my browser is using, which is 62465. Okay, and then we can go into the hypertext transfer protocol, the HTTP. In here we have the get HTTP 1.1. It creates a persistent connection to a website, and the request method is get, and here the request URI. So what happens here, you are requesting the path, the slash on the website. Okay, and our host is the www.utam.edu.my, which I have requested just now, and the connection is keep alive. Okay, and this user agent over here, right here, it tells us what browser are we at, what browser are we using. You can see here the Chrome and the version and that kind of stuff. Okay, and here the language is English US. Okay, so that's how we do a basic protocol analysis for HTTP. Thank you.
Hey guys, so now let's continue our tutorial. So for this tutorial I will use ICMP filter. So first of all I want to tell you guys that what is ICMP? ICMP is a convenient protocol to IP that helps IP to perform its functions by handling various error and test cases. So we launch the Wireshark first. So this is the Wireshark network analyzer. So here is the list of interface. I use Wi-Fi connection. So at this section I type ICMP because I just want to capture ICMP packet only. Then we click this, and as you can see there is no ICMP packet that has been captured because we must ping to capture the packets. So ping is a standard command line utility for checking the another computer is responsive. So right now I will ping to my university website edu.my, and you can see here we've got a reply back. That means this website is respond. So we go back to Wireshark. So here you can see that we captured the ICMP packet data, and now I will just tell you guys, explain to you guys what does this means. So first of all, each echo request and echo reply has its own type and code. So for the echo request here, echo request, we have type it and the code is 0. while for the echo reply here we have type 0 while the code is same. And next, each echo request and corresponding echo reply have the same identifier value, and the same sequence number value. The value are used to match the echo request to the right echo reply. So this is the echo reply. As you can see, the identifier and the sequence number value are the same. This is the echo reply, and we go to echo request. As you can see, the identifier is 1 and 256, sequence number 179545824. So it seems because it want to match these two. So next we go to data. The data is the same because the echo request sender can use any convenient data, and the echo reply sender will copy its data from the request so that the payload returns to the original sender. So as you can see here, this data at the echo request is same with the data at the echo reply. So that's all from me about ICMP filter. Thank you.